Now let's work the following function that we're gonna call f of x. It's square root of x plus 1. Okay, the first question that we need to answer is, what's the domain of this function? So remember, domain, when having the square root of x, that everything inside the square root must be positive. So in this case, we need to have x plus 1 bigger than 0. And this means after adding minus 1 to both sides is that x is bigger than minus 1. Okay, so the domain here is the set of x such that x is bigger than minus 1, or we can use the line to say this is 0 and this is the domain here. Okay, so now we can graph this function. Okay, we can graph it, but before graphing it, we see that when x is bigger than minus 1, we have the square root of x plus 1 is bigger than 0. That means the domain is 0 plus infinity. And we plug some special points. So when x is minus 1, we have 0. When x is 0, we have 1. Okay, we have these points. So, but we can deduce the graph of this function from the famous graph of the square root of x. So we know that the square root of x is something like this. Okay, it's defined on the set of positive values, and its range is the set of positive values. So what's the relation between the square root of x and square root of x plus 1? So this one was shifted left from the square root of x by minus 1. So here we go back here to minus 1, and we have this point here. When x is 0 is 1, and this is our graph approximately. So this is the square root of x plus 1. So this is minus 1, this is our domain here, and this is the range. Okay, so we see it from here. So this is the graphical representation of the square root of x plus 1. Okay, another function that we can deduce is the g of x, defined by minus square root of x plus 1. What's this function? So in this case, the relation between f and g is that g is just the mirror image of f with respect to the x-axis. So it's here. Okay, so it's this one here. I'm just trying to make this minus 1 clear. Okay, so this is the graphical representation of the square minus square root of x plus 1. Notice that what happens in this case is that the domain is the same, but the range has changed. The range for f of x is here, is this set of positive values. But for the g of x, okay, the range is here. Okay, it has changed completely. So it's like it flips with respect to the x-axis. Okay, we can prove the range graphically and algebraically, but it's a very simple case. Okay, we can use that anytime we multiply by a negative number, we flip everything and get the set of negative values. So the range in this case is minus infinity 0. Okay, another function that we can use and that's helpful to graph is the absolute value of this function here. Okay, So the absolute value of the let me write it down here so I can have more space. So g of x, the absolute value of square root of x. Okay, so what we know about the square root, so in this case, what's the domain? So this is always positive for all x. So the absolute value is always positive. So we don't have a problem. So the domain in this case, the domain is the set of all the reals. We call it R, or we write it minus infinity plus infinity. Okay, and to graph this function, we just need to see that this is an even function. Why is it even? Because we know that an even function, if it satisfies g of minus x, is equal to g of x. If we plug the minus here, we get the absolute value of minus x is equal to the absolute value of x, and that means g of minus x, it's g of x. Okay, now for the graph of an even function, you need to graph only one part. So we graph the set of positive value. Okay, so here we know that the square root is like this. Okay, so to get the part for negative values, we just take the mirror with respect to the y-axis. Okay, so this is our function. So this is the square root of x, the absolute value of x. Okay, this is 1, and the domain is this one here. The range is this one, 0 plus infinity, and the domain is this whole line. Okay, so we can deduce the absolute value graph from just graph of the square root only. Okay, we will add more basic functions to get these ideas. These are very simple. We don't need derivatives, we don't need limits, but later we're gonna need limits and derivatives to be able to graph all of these functions. Thank you.